So let's go and start that. Okay, so we're gonna start chapter 9 by looking at the formulas for chapter 9. Okay, so here, just like chapter 8, okay, it is still about the hypothesis test. So this is your test stats. Okay, this is your chapter. This is the step 3 in the hypothesis test procedure, right? You test statistics. This is how you compute. So let me zoom in a little bit here. Now, chapter 8 is about one sample or one populations. Chapter 9, we're going to extend it to two populations. So you're going to have two samples for two populations. Okay, so look at the statistics for Z for the proportions. Okay, so you have the p hat 1, p hat 2. So p hat 1 is from the sample 1, p hat 2 is from the sample 2. P1 is for the population 1, P2 is for the population 2. Okay. Here I have this P bar, Q bar. Now, just like the P minus, just like the Q is equal 1 minus P. Same thing here, the same thing happened here. So Q hat will be actually, Q bar will be 1 minus P bar. Okay, so you see the trend. Q hat is 1 minus P hat. These are the trend that you saw already. So this one you saw, I think last chapter 8 or chapter 7. This one you saw that in chapter 5. Okay. Here, this is chapter 9. So once I got the P bar, I can find the Q bar by just using this formula here, same thing, okay? Is now they told you to compute the P bar by just simply take x1 plus s2 n1 plus n2. Again, x1 just tells you that this number here came from the first population, actually the first sample. N1 is the first sample size. This is the first sample size. N2, that is your second sample size, right? I mean, common sense here. X2, well, that came from your second sample. Okay, so but look at this formula. It should be hard to read. It shouldn't at all. Okay, remember you can use this for the test. Okay. Now let's look at the T. X bar, again, that is the sample mean. 1 stands for first population, actually first sample. 2 mean second sample. Okay. Mu1, first population mean, right? Mu2, second population mean. Okay, obvious. S1, S squared, that's the variance. S1 is its standard deviation. So this is x squared, so that is the variance. 1, well, the variance for the first sample. Okay. Same thing here for the second sample. So the 1 and 2 tells you what this the sample that you pick. Now I can name the first number, the first sample I see 1, and then the second sample I see 2. Or I can switch and say I'm gonna name the second sample that I see will be first sample that I choose, and then the first sample that I see I will pick to be the second sample. In other words, I pick the second sample that I see to be x1 or x bar 1, and then my first sample I will say will be x bar 2. So this is just the way you assign which sample you were talking about. Okay. So like you can make x1 to be for weights, and then x2 to be for distances. Or you can make x1 to be males, and then s2 to be females. So it depends on the problem. Okay, now here again, if we don't know the sigma 1, sigma 2, then we have to use the t-test, the tested t, the test statistics t. But the formula is not that bad, right? Look at that. Okay. Now here's the degree of freedom. So it says df is smaller of n1 minus 1, n2 minus 1. Well, which one smaller, then pick that one as your degree of freedom. Okay. Now we're gonna skip this part here because in real situation, we always do not know the standard deviation for the population. Okay, we always don't know that. But we not assume they're to be equal. Okay, so here, so that's why we kind of drop this one. Okay, we're gonna focus more on this one. Okay, where we don't assume anything. Okay, we don't assume that sigma 1 will be the same as sigma 2. So we don't know sigma 1, sigma 2, then we don't need to assume. And this is more real life situation. This one here is just do some experiment. If we assume that they're the same, then we do this. So that's why for more practical purposes, we're going to focus on just this one here. You can ignore this part. All right, let's look at another formula, right? So here, now we're also going to ignore this formula. We could focus on this two. Okay, so this is the t-test t. We have two means, and the difference is this is a match pairs. So you have a pairs like a before and after type of a study, like weight loss program, right? So things like this, we use the t-test or the t-statistics to help us out for the test statistic calculation. Okay. Here we have the F test, they call F. This is the T, the F. So this is just the first variance square divided by second variance square. And they will require that the first sample that they have, that variance will be bigger or equal to the second variance. Okay. Now, you might wonder what's stands for, D stands for difference. Okay, so when we get to the example, we can talk about the difference. And mu D just means that you compute the mean for the differences. Okay, SD just means that you're gonna compute the standard deviation for those differences. Okay, like I said before, like this is like a before after program, like weights before the program and then weight after the program, and then D, those are differences, how much different from each person, and you debug means you just take the average of those differences, right? Here we talk about, we assume to be a for the everybody, for all the population who take the program, right? So we can assume that works for everybody. That program works for everybody. So that's why we assume that, well, we claim, right, that the mean for all the people who will take the program, and those mean based on the differences. Okay. Remember that hypothesis test is all about population. So we gonna claim about population. I mean, we make a claim about population and then we test on it based on the data that we collect. Okay. We'll get to more of this one of the example. Okay. All right. Now I want to go ahead and now I assume that you kind of get used to the hypothesis test procedure that you saw in chapter 8. Okay. So I'm going to go ahead and do the example. So I want to go ahead and do the couple example here. Same procedure, okay, nothing new, okay. Okay, so here is the example. This is, if you think of in terms of our textbook, this is the section 9.1 or section 1 of chapter 9. Okay, so let's do two of these, or at least a couple more of this problem. Let's do some example. The hypothesis test of two populations. Okay. So, all right now. So to combat high costs of fuel, American Airlines using small plane on the nonstop flight from LA to Seoul, South Korea. When use a smaller plane, the flights had to stop on 43 out of the 1100 flights. When use a larger plane for the same routes, they stopped on a 12 out of the 1100 flights. Okay. Use alpha 0.05 to test the claim that the larger planes make unscheduled stop less frequently. Use the p-value method. Okay, so we want to divide it into two populations or two sample. The first one is smaller plane. Okay. Second one will be a larger plane. All right, so we're gonna say we'll make some we're gonna gather some information here, right? So we do this. So this is some we're gonna say this is a smaller plane. I'm gonna say now because they asking about the larger plane, okay? I'm gonna say now again you can choose the small plane to be the first populations or second population. It's up to you. I'm gonna choose the larger plane to be my first population. So I'm gonna say sample one will be the larger plane. So large planes. Okay. And then we'll make the sample two to be smaller plane. This is the small plane. All right, so let's gather some information here. Okay, so now for the large plane, we're told that they stop at 12 out of 1100 flights. So it tells me that X is 12 and N will be 1100. Okay. Now for this small plane, we're told that they stopped 43 out of 1100. So we're gonna put X will be 43. And same size, right? Same size. They're both at 1100 flight, that is. Now I'm gonna go and we're gonna use now the 1 and the 2 to tell me which one it is, okay? So I'm gonna make a subscription 1 for X, 1 for N, like this, okay? So now I know that the X1 belong to the large, I'm talking about X1, we're talking about large planes. And 1, we're talking about large plane, okay? So now X2 will be a small plane, and also N2 will be a small plane. Okay. Like I said, you can choose sample 1 to be small planes and sample 2 to be large planes, up to you, okay? Whichever you choose, you just have to stick to that, okay? Stick to that. Now, because of this, X out of N, I'm gonna say that, so we're gonna do a P hat, we'll do a P, how do you say P hat? When we insert the P hat there, see the P hat symbol. Let me put the p hats. Where does it go? There. Yeah, so again, the p hat, I'm gonna say now that it is a p hat, but because this is my first sample, so I'm also gonna put a I'm gonna put a subscription here also. So let's do a subscription. Let me put a subscription first. We'll do a subscription. So here be 1, and that is the p hat. And so you can see that p hat 1 will be then will be this guy, will be x1 divided by x2 over over n2. Okay. So remember that p hat is x divided by n. Okay. So it makes sense that if I'm going to do a p hat 1, I will put x1 divided by n1. Okay. I do the same thing with my second sample. Not going to change to be, again, it will be just 2. So everything changed to 2. Okay. To get my second sample p hat, that is. So for this, okay, let's go back to the p hat 1 then. We're going to go ahead and put equal 12 out of a what n, so which is 1100. So if we do the math there, I should get 12 divided by 1100. Let's see. So bring your calculator. 12 divided by 1100. I'm gonna put 0.0109. I'll use 4 digits. I guess we can just route it to the we can use the 3 digits decimal if you want. Anyway, I'm gonna keep it at the 4 digit here. Okay. Okay. So for the second sample, which is this small plane, then for the p hat 2, we're gonna go 43 over should be this number. Like that. So it'll be 43 divided by 1100. And that will give us, if you do your calculator, 0.0391. Okay. I'm just routed to 4 decimal digits. Okay, so those are how you get the p hat and q hat. I mean, this is nothing new. We've seen this already for the p equal x divided by n. Same thing here. So just be aware of the notation. Now, if you want to guess, you can see that P1 will go with the second, will go with the larger plane, right? P1. And also P2, that will go with the smaller plane. Okay. One for the smaller, one for the large planes, and two for the smaller planes. Okay. Now you want to keep your I guess you want to keep your sample to be different. Okay, you want to do that. Now, remember that we have to go for the claim, right? So we're gonna say the claim. What's the claim gonna say? The claim says the larger plane makes stops less frequently. So what does that mean? In other words, P1, remember P1 is for all the small plane, stop less frequently. So in other words, they stop less flights, they make it less stop. So the proportion of stop or the percentage of stop will be less than P2. Okay, so you should be able to tell the difference between P1 and P2. And translate the claim to be a symbolic like this. Okay. Now, if you read like this, right, it says the larger planes make unscheduled stops less frequently than what? Well, than the smaller plane. Okay. Because here we only talk about larger plane and smaller plane. So when the claim says the larger planes make stops less frequently, then they're talking about less than the smaller planes. The way the plane makes unscheduled stops. Okay, so hopefully that makes some sense. Now, as before, H1 is always says not always say equal. So I'm gonna say P1 will be always the same as P2. That's gonna go to my H1. I'm H0. And then H1, remember that always says that I will have only strictly smaller or bigger or not equal. So here the claim is going to go with H1. Okay. So the same thing applied like chapter 8, just that you just have to look at the claim and pick which one is go where. Okay. All right. So you see that this is a little bit different from chapter 8. Because chapter 8 we have a number, right? Here we don't have a number. We kind of like comparing one sample to the next to make a prediction about those two populations. Okay, those two related populations. All right. Step 2, alpha. That is just simply 0.05. That's easy. All right. Now, step 3, the test stats. Again, we talk about two proportions. As I showed you before in the formula sheets, we look at the proportions, and we only see just the first, we only see only one formula for that, right? This guy right here, okay? It's only one. So we're going to use that to help us out for the test test statistics. So we're going to use Z, and Z is equal to this thing right here, okay? So we're going to go back to this worksheets, and we're going to write down the formula there. Okay, so the test statistics for this will be Z. So I'm gonna go ahead and write this down to save some time. You don't want to use it computer to write it. So Z is said P hat 1 minus P hat 2 minus P1 minus P2 divided by, I think the formula says square roots. So we'll do the square roots. The square roots of P bar Q bar over N1 plus P bar Q bar again over N2. Now don't forget that we're also told that P bar is x1 plus x2 divided by N1 plus N2. And then we also notice that Q bar is 1 minus P bar. Okay, so those are the formula that we have to use for this. So we know our P hat 1 and P hat 2, right? We just compute right there. Okay, we just did that. And then we know our x1, x2, we know n1, n2. Let's compute the p bar here, because we do have the x1 and x2, n1, n2. So I'm gonna put the numbers in. X1 is says 12, x2 is 43, so we'll put 12, 43. So 12 plus 43. And 1, we taught it is 1100. And 2, the same thing, 1100. Okay, so let's do the math there. This is 43. So 43 plus 12. 43 plus 12 is 55. Divided by 1100 times 2, which is 2200. Okay. Now, if I take 55 divided by 2200, I will get P bar to be 0.025. Okay, so that's the P bar. To get the Q bar, again, just simply go 1 minus, the Q bar, so 1 minus P bar, which is 0.025. So here, my Q bar then will be 0.975. All right, now we're almost done. We got our, the formula that is. We got the P bar, we got our Q bar, we got the N1, N2. Now let's play with this thing here a little bit here. I want P1 minus P2. What is that going to be? So it turns out that if I go from here, if I go from there, okay, from the H1, if I go P1, let me do a color here. I go P1 equal P2. Then I can see that if I were to subtract just the, if I do some little bit, if I do some algebra here, I would say minus, let's do a minus P2 left and right. So you can see that P1 minus P2 will be 0. And so this guy then we're going to go to 0. This guy there. Okay. So in your formula sheet, you might want to put something like P1 minus P2 go to 0. So let me switch back to the formula sheets here. So you might want to say this guy go to 0. So you might want to cross out here and say 0. Okay. It also turns out that it will happen the same thing with this guy here, 0. Okay. So mu1 minus mu2 also going to go to 0. Now the fact we do that is because we always going to have like mu1 equal mu2 in the H0. So you always going to have mu1 minus mu2 will be 0. Okay. It's always the case. Okay, so you might want to put this on your notes and formula sheets here. Same thing with the, well, we don't use this, so yeah, we're gonna use this too. All right, now let's go back to the formula here. Let's gonna put in the formula. So we're gonna go ahead and plug it in our formula, our numbers, that is. So we'll go I'm gonna totally ignore this part here because it goes to 0. That would just It's not there. So we go P1 minus P2. I mean, P hat 1 minus P hat 2. Okay. I'm just ignore this part. Okay, this part, I just pretend it's not there because it goes to 0 anyway. I'm just going to focus on this part and the rest. Okay. So P hat 1 is 0109. 0.0109. P hat 2 is 0.0391. Just put it there. Okay, so 0.0109 minus P hat 2 is 0.0391 divided by the square root. Yeah, put it in. Q bar we got to be 0.02, so 0.25 times the Q bar 0.975 divided by N1, which is 1100. Multiply, actually, it is a plus, multiply, plus, same thing here, that's 0.025, 0.975 divided by 1100. Let me rewrite this again so you can see a little bit better. So 0.25025 times 0.975. Okay, so use your calculator and see what you get. So bring up your calculator and let's compute that. So let's plug those in. See, 0.0109 minus 0.0391 divided by the square root of this guy, right? So put those in. If I do that, I will get a Z is, I got negative 4.236. Okay. Now we got so the hardest part is just the test stat here, okay? Just the statistics part is the hardest one. The rest should be straightforward. Okay, now let's go to step 4. We're told to use the p-value method. So from here, I'm gonna find the p-value method here. We're gonna go, first of all, we want to know, is it left tail, right tail, or what? Okay, so recall from chapter 8, if the H1 has the less than sign, it means you have a left tail test. So I'm gonna draw this graph, Z graph, actually the normal curve on the left tail test. So we draw here. Let me clear that first. Okay, so you gotta know how to determine the left or right tail. Okay, by looking at the H1. H1 less than left tail, bigger than right tail, not equal two tail. Okay, same thing. So I'm gonna draw here left tail. The area on the left side, and the test statistics for this is Z is negative 4.236. If I got that Z, the area on the left that I just drew, that area is always the p-value, okay? All right. So look at your table, look at the Z's left area, which is the left side, area from the left of the critical value Z, no, sorry, of the statistic Z, okay? Yes, so that's a good one that we talk about p-value, we talk about statistics, okay? Again, if we talk about p-value, we talk about the test statistics. Area on the left, on the right, or both. We talk about critical value, then the area is supposed to be the alpha, which is now called the critical region. Forget about that, okay? This is from chapter 8. So same thing. So look up from the table, and you should see the area on the left, the p-value then will be 0.0001. Okay. This is when the Z is less than negative 3.5, right? Because our Z this case is more than negative 2.5. Now let me go back to the table again here, right? So this table, I go back to the Z table. I look for the area of the Z score negative 4.3 something. So right here, you can see that it says right here that negative 3.5 and lower. This is your area on the left, 0.001. Okay. Now you can use your calculator if you want, if you know how to do that. All right, so a table give us the area on the left side of Z less than negative 3.5, and anything lower than that, in this case we have negative 4.3, so we're gonna use the area on the left 0.001, and that area turned to be a p-value. So our p-value then will be the 0.001. Now, step 5, reject or not. Again, you want to go back to your formal procedure from to the 8, and we're not gonna, you should kind of know by now. Okay, so we're gonna put p-value. We put p-value against the alpha. P-value is 0.0001. Alpha, in this case, is 0.05 right here, right? 0.05 right here. So you can see that the p-value is way smaller. Okay, because again, the p-value is just simply 0.001, alpha is 0.05. It's much smaller. Okay. So because of that, we're gonna say we are gonna reject. Okay. Since p-value is less than alpha, we're gonna reject H0. Okay, remember, if p-value is less than or equal alpha, then you're gonna reject H0. If p-value is bigger than alpha, then you go to reject H0. Okay, now because of this conclusion, we're gonna look at the original claim and the result of the result from previous step 5. So reject H0, and the original claim says, what it says, right? P1 less than P2. So clearly you can see that this is not a, I mean, the original claim does not include equality. Equality. Okay. So the original claim does not include equality because it's not equal. So based on that, based on the wording, then you're gonna say there is sufficient evidence to support the claim that what? Well, whatever the claim is. So I'm gonna go and insert the claim that that larger planes stop less frequently. Okay, so that's how you do this thing again, just like to the A stuff, same procedure. You can see that this thing, I mean, the hardest part is probably the formula, how to compute the test statistics. Okay, so this is a little overview pretty much from chapter 8 also. Okay, so you will surely you're gonna see this again and again for the next exam, pretty much.